Yes, can you hear me? Sherwin, can you hear me?
Yeah. Can.
Can you see the screen?
Yes.
Okay, right. So now we see the question you asked me the other day, right? Okay, okay, move forward here. Right. Um, the question that you asked me the other day regarding the composite function, this one, right? Y equals to 1 over 2x minus 3. Now, this this function you cannot split up into two parts. For example, 1 over 2x minus 1 over 3. You cannot split that way. Now, the splitting up is only valid when you have only one term at the bottom. One term at the bottom, then you split up like this. 1, x, 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 x. However, if you have two terms like this, x and 1, then you cannot split them up and say something over x and something over 1. So cannot. Okay, so come back to our problem here. Okay, this one. So this function 1 over 2x minus 3, you cannot split up. So what you can do is you take the whole thing up and become negative 1. So when you have a bracket raised to the power of a certain number, whether it's fraction or whether it's integer, then this, okay, so then this becomes a composite function. Okay, so this becomes a composite function, and something raised to the power bracket raised to the power something. So this becomes a composite function. So when you want to differentiate the composite function, what you need to do is the first step, you differentiate the bracket here. You bring down the negative 1, then negative 1 minus 1, or whatever inside the bracket, you copy back here. So this is the first differentiation. Bring down the index, then the bracket remain the same, but the index less by 1. So this is the first part. Now the second, differentiate the function inside the bracket. When you differentiate the function inside the bracket, you get 2. 2x become 2. Negative 3 becomes 0. So the 0 you can just ignore it and you just write down 2x become 2. The next step in simplifying is you have to gather all the numbers. Numbers 2 and negative 1 becomes negative 2. Then this bracket raised to the power negative 2. Now if you want to make it look nicer, then you can move the bracket below to the denominator. When you remove to the denominator, it becomes negative 2 over 2x minus 3 to the power of 2. But the negative you can put outside also. You can do it in many ways. You can do it in many ways. You can do it like this, right? You can put the negative outside. Okay, the negative you can put outside at the center like this. Okay, so they want you to find what is the value of the derivative when y equals to 1. Okay, so you can substitute y equals to 1 and find out what is the value of x. Right? Y equals to 1, y equals to 1, then comma, y equals to 1 comma 1 equals to 1 equals to 1 over 2x minus 3. 2x minus 3. Okay, so you have next step 2x minus 3 equals to 1. So the function at the bottom you bring, the expression at the bottom here you bring over to the other side. So
Teacher,
yes,
for the 2x minus 3 raised by the power 2, the 2 don't need to write already. Yeah.
oh yeah, yeah, we have to find out the value of x first. What is the value to substitute in first? Because you want to find dy dx, isn't it? They ask you to find the dy dx. To find the dy dx, I have to substitute in the value of x, not the value of y. However, the value of y is given and the value of x is not given. So from the value of y, I try to find what is the value of x first. Then only I substitute inside the dy dx. Okay or not?
Okay, teacher.
Okay, so I find out what is x first. So 2x equals to 4, x equals to 2. Okay, so x equals to 2. Now I can put inside the dy dx. Okay, dy over dx. Yeah, this one something. Okay, this one. So dy dx equals to this one, not the y anymore. Put inside the dy dx. So it's negative 2 over 2 bracket 2. The x is 2, minus 3. Minus 3. Minus 3 raised to the power of 2. Oh, is this okay?
Yes.
Okay, right. So okay, then we find out what is the value of dy here. Oh, yeah. Okay, what is the value of dy dx? Negative. This one is 2. Negative 2 over 4 minus 3 is 1. 1 square is 1. 1 square is 1. So answer is negative 2 equals to negative 2. Okay, right. So okay. So try to check answer. What is this? 3c, 2.4, 3c.
Negative 2, correct.
Negative 2, correct. You checked
Yes.
the answer already.
Yes.
Okay, then you check the answer, then okay. Now we come back to this one. Okay, so we come back to here. So so next time when you see there is a function, this type of function 1 over something. Now if the function at the bottom consists of more than one term, you use the composite function. You use the composite function. If the denominator has only one term, just the x only, then you don't have to use the composite function. You just use uh, the normal differentiation, the basic differentiation. Okay, the basic differentiation. Any question from here?
No, teacher.
No, no question. No question. This is what we have done last week. Right? This is what we have done last week. The composite function. So composite function, the the function inside the bracket is linear, is the easiest. If it is not linear, when you differentiate, you become something like this. It's more difficult, right? And this one linear, are there? Here I have shown you that you need to change the thing to the negative index before you can differentiate. So this is the example that is related to the question that I've shown you just now, right? Now, other than having a function at the denominator there, right? You may also have a function inside the square root sign. So you have the square root sign, you have to change the square root to fraction. If you have function at denominator, you have to change the index to a negative number. So these are the two things that you need to know, right? So if you don't know this, then you cannot continue, right? So differentiating the function in this way is known as composite function, right? Using the chain rule. Okay. Next. Okay. So today we are going to do a new rule. So the new rule is called the product rule. And this product rule is used to differentiate the product of two functions. Okay. Now, what do I mean by the product of two functions? So if you look at example number 1, y equals to x minus 3 bracket, 2x plus 1, and another bracket. Now, these two brackets, they are actually the product of two functions, two different functions. So this you can, the easiest way will be to expand the bracket, right? Expand until you have one term like that. Expand the bracket until you have term by term like this, then you differentiate. Or you have something like this, you expand the bracket until you have one by one, then you differentiate. But over here, I'm not going to use that method. I'm going to use more difficult method. But in the exam, if you see simple questions like this, it is better for you to expand. But today, I don't want to expand. I want to use the product rule because this is the easiest, the simplest example of product rule. So if I solve this using product rule, then you can understand how to use the product rule, right? If I use the expansion then one by one, then you cannot see how to use the product rule. Okay, now if I start with more difficult example for the product rule, then you cannot follow, right? So it is not because I purposely want to use a easy question, I want to use difficult method to solve it. No, I want to show you how to use product rule, that's all, right? So when to use product rule? When you see you have two function, one bracket and another one a bracket here. Now, is it necessary to have two bracket? Not necessary. Sometimes you don't have two bracket. You see here, it's just an x and one bracket only. So it's still considered two different function, a product of two different function. The product is 2x cubed 1 multiply with 1 minus 5x. So this is also the product of two functions. So product of two functions, not necessary you have two brackets. Not necessary you have two brackets. You see here, I don't have two brackets. I have this and this, right? I have one bracket, but then the x outside is considered one function, right? Here we have two brackets. Two brackets, then this is obviously is product of two functions. Okay, coming back to example number 1 here, I have two functions. One function is x minus 3. Another function is 2x plus 1. I want to find the dy dx for the product of these two functions using the product rule. Okay, So you see any, oh, one more come already, very good. Ang Yifen, Jian Dong, Jia Yan, Sherwin, and Zini, right? So you didn't miss anything. I'm just starting the product rule. Okay, now product rule, the first function, I use pink color. The second function, I use purple color. So how to use the product rule and what is the product rule? The product rule is like this. dy dx equal to u dv dx plus v du dx. I'm not going to do it this way because it will your your ability to uh, perceive function, your ability to see the function is not very good. So if I tell you like that, v du dx u dv dx, maybe you cannot follow. So again, I'm going to tell you how to differentiate by words, by word of my mouth. And this is between all of us here. Other people, when they listen to what, they don't know what I'm talking about. Okay, so you listen to my words, Okay, now there are two functions here, one pink color and one purple color. Now what if you want to differentiate two functions, you do it like this. The first bracket you differentiate, you write down the what is it here. Then the second bracket, don't differentiate, just copy down, just keep the function here. Then plus, this time you differentiate. Just now you didn't differentiate this, now you differentiate this, then the other function you just keep. Do you know what is my mouth? They said in Mandarin, they said rao kou ling. Then maybe primary school that time you learn. Okay, so I will tell you the rao kou ling. Differentiate, keep, then differentiate. So the first time you differentiate one, then you keep one. Then the second time you differentiate one, the other one, then keep the other one that you have differentiated. So you take turn to differentiate. No? Differentiate, keep, then differentiate. Take turn, differentiate them one at a time. Don't differentiate two at a time. You differentiate two at a time, then everything is wrong, right? Okay, one more time. Okay, so the first one I differentiate, the pink color one I differentiate. Differentiate x minus 3, I get 1. Then this second one, I just keep 2x plus 1, I just keep here. Now just now I differentiate the pink color. Now I differentiate the purple color. So differentiate 2x plus 1, answer is 2, right? Then this one, the pink color, I just copy down exactly the same and keep. Settle. I have differentiated the product of two functions. So now the next step is simplification. So you just expand lah. 1 times 2x, 2x, 1 times 1, 1. 2 times x, 2x. 2 times negative 3, negative 6. Then you add them up, 4x. Then this one is minus 5. Okay, any question? Any question?
No, teacher.
No, no question. I disappear already, one person left. Oh, go to makan. Chen Tong go and makan. They just came back. Okay, right. No question, then I show you a slightly more difficult example, right? Slightly more difficult. We still have two functions here. The 2x cubed is the first function. 1 minus 5x is the second function. So these two functions, I want to differentiate the product of these two functions. So the way is differentiate one first, keep this one, then differentiate the other one, then keep. Okay, take turns to differentiate them. Right? If just the first time you differentiate one, then the second time you differentiate number two, the next function. Okay, then the other one you just keep. Okay, right. So now to show you what I mean by differentiate one, keep one, differentiate one, keep one, like that, I color them. Okay, the first function I color it as pink color, 2x cubed. The second function I color it as purple color, 1 minus 5x. Okay, so now I'm going to differentiate, keep differentiate lah. Okay, so now start differentiating already. Okay, differentiate the pink color, 2x cubed become 6x square. The 3 you bring down becomes 6 lah. Multiply by 2 becomes 6. Then the 3 becomes 2. So I differentiate the pink color. So the purple color, I just copy 1 minus 5x, 1 minus 5x. Then the sign is plus. The sign is plus. Okay. Now just now I differentiate the pink color. Now I differentiate the purple color. Differentiate the purple color, I have 1 becomes 0, negative 5x become negative 5. So I'm only left with negative 5. Then the other function, 2x cubed, I just keep, don't do anything. Just copy down the 2x cubed. Okay, so differentiation part completed. Now, what you need to do now is to simplify, right? Simplify. Okay, expand 6x squared, then minus this, multiply by this is 30x cubed. Oh, negative 5 multiplied by 2 is negative 10x cubed. So answer is 6x squared, there's only 1. So you just copy down 6x squared. X cubed, you have 2. So you combine the 2x cubed together, you get negative 40x cubed. Any question? Oh, centong makan already ah? Sudah? Belum? Belum? Then you can take your rice, then look at the computer and eat. Okay Nah, makan sambil berenang. Not makan sambil berenang. Oh, sudah. Okay, okay. Sudah. So I thought you menyelam sambil minum air. Never mind. Makan sambil belajar. Classroom cannot lah. Online can. Okay. Any questions before I go on to more difficult examples? More difficult examples, right? I think maybe you try some questions first, so that you are confident, you know what to do. Oh, can you try number 1A first? Today my mouth very sticky. Cannot.
Okay.
Must have a drink, rinse my mouth so that I can talk. Because I don't know why today very the mouth. So you try number 1A. I go and bring myself a cup of tea. Try 1A. So my tea is here already. Can see my tea. Okay, I'm back. Can you hear me?
Teacher, your camera is closed.
Camera close. Why? Okay, can see or not? Okay,
Yes, teacher.
okay. Can see the screen? Can see the screen or
Can,
not? Can.
can.
Okay. Can hear me? Can see the screen. Have you tried A? A. Now no more saliva already. My mouth very clean. I can pronounce the word correctly. Just now all the saliva there. Oh, drink some tea. Okay, can you do number 1A? 1A, boleh?
Can, teacher.
Can. Okay. You check the answer at the back there, right? If cannot, then afterwards you ask me, I show you. Huh? Okay, right. We are going to look at more difficult question. Now, why I say more difficult? So far, you have learned two rules. The two rules, they are the chain rule and the product rule. Now, each time I show you the examples all along, either they use chain rule or they use the product rule. But that is not always the case. Sometimes you may have a function that has product and composite function, the product of a composite function. So you know how to differentiate. So I'm going to show you how to differentiate problems where you have a composite function multiply with another function. Okay? So we are going to use two rules at one time. Okay. Now what I mean by that, you're going to see. Okay. Okay. Now this problem, example number three, is this example number three is the product of two functions. The two functions, they are 2x and 1 plus 3x raised to the power of 4. So we have two functions there. The first function, okay lah, 2x, no problem lah. But the second function is a composite function. It is 1 plus 3x raised to the power of 4. So can you see that two things are coming in at the same time? Okay, okay, can see. Now another thing I want you to note is that the number in front here, the 2 in front here. Now, the 2 in front here, you can give it to the 2x and consider it as 2x. Or you can consider the 2 as a separate number. You just leave it aside and you just the function, the first function is x and the second function is 1 plus 3x to the power 4. Now,
Teacher,
yes,
can you repeat one more time?
okay. Now you look at the example number 2. You see I have a number 2 here. Example 2, I have a number 2 in front.
Yes.
Example 3 also I have a number 2 in front. Now this number 2 in front can be treated in two different ways. The first way is the number 2, you give it to the first function. Okay. The second way is you treat the number 2 as coefficient, as a number, you leave it aside. And the x alone is the function. Want to repeat or not?
Okay, understand, teacher.
Understand. Oh, so clever. Eh? I understand. Other girls can understand or not? Okay, one more time, one more time. Okay, for those that don't understand, right? You see the example 2, there's a number 2 in front. Example 3, there is a number 2 in front. Now this number 2 can be dealt with in two different ways. You can deal with this number 2 in different ways. One way, in example 2, I give the 2 to the x cube. So I consider the first function as 2x cubed. The first function is the whole thing, 2x cubed. Then I differentiate as I have shown you earlier. Now in this example 3, I want to show you a different approach. That is, the number 2 here, I'm not going to give it to the x. So I consider x as a function and the bracket behind as another function. Then how to deal with the 2? Right? So the 2 is considered a number. You just put it outside and don't differentiate it, just leave it there. Okay, so I'm going to show you how I'm going to do it, right? Okay, so now there are two functions. One function, pink color, x. Another function, 1 plus 3x raised to the power of 4. And this second function is a composite function. Okay, right. The way we are going to do it is differentiate the pink color, keep the purple color. Differentiate the purple color, keep the pink color. Okay, no? The method. Other people maybe they don't understand because I use color and I say differentiate, keep different. Maybe other people don't understand. But you know what I'm talking about, right? You know, right? Okay, so now two functions, one pink color, one purple color. Now the number 2, I didn't put it inside this x there. So this number 2 is just like a number, the ax to the power of n. The a don't differentiate, you just keep it, you just differentiate the x. So same thing here, 2 then multiply by x. The number 2 I don't differentiate, I put it here. Then the x I differentiate become 1. Purple color, don't differentiate, I just copy down, right? Okay, now plus, purple color just now I have differentiated, and the 2 don't differentiate, you just copy in front. 2 is just a number, you copy in front, don't differentiate. Purple color just now I differentiate, now don't differentiate, I just keep. Then now I'm going to differentiate the purple, this is purple color, pink color, sorry, this is pink color, this is purple color. So pink color I just keep, purple color I differentiate. Now you may ask me, hey, can I differentiate then put in front, then this x I put behind? Can, because multiplication is commutative. You can interchange the position. So whether you want to differentiate the this function, then the x1 you put behind is also can. As long as you differentiate one and you keep the other one. Who in front, who at the back, it doesn't matter. So far, okay or not?
Okay. Okay, teacher.
Okay, very good. So many okay, that means okay. Okay, now I repeat, the 2 is a number, don't differentiate. The x I differentiate become 1. Then this purple color, I don't differentiate, I keep here. Now just now I differentiate the x. Now I don't differentiate the x, I keep. Now I differentiate this bracket here. Now this bracket is a composite function. So when I differentiate the bracket, I have to differentiate using the what rule? Chain rule. Using the chain rule. So chain rule means you have to differentiate 2 times. The 4 you bring in front. Then this bracket you copy down, 1 plus 3x. Then the 4 reduced by 1. Then differentiate what is inside the bracket. 1 plus 3x become 3. Now, so far, can understand what I'm doing or not?
Teacher,
Hmm.
why the 2x, we only take the x?
Okay, I explain. That's the first lesson. First lesson. Now you see here, 2x cubed. What are you going to differentiate? Differentiate the 2 or differentiate the x cubed?
Uh,
The 2 you don't differentiate, isn't it? You just copy down, right? Then the x cubed you differentiate become 3x squared. So as a
yes.
result, you get 6x squared. Okay,
Okay, okay.
okay, the two, they are numbers in front, the coefficient of the function. You don't differentiate, you just copy down lah. Just like the a x to the power n. There, the a is still there, you don't differentiate. You only bring down the n. Okay, right. So we come back to this one. So this one is like that. So we are at this step here. Now this composite function, because it's it has the index like that, it's a bit difficult. So never mind, I simplify first. So simplify 2 times 1 is 2. 1 plus 3x to the power 4, I just copy down here. Didn't do anything. Now simplification means you must gather all the numbers. So from the term at the back there, the numbers they are 2, 4, and 3. 2 times 4 times 3, 24, right? 24. Then x, then this bracket. So I copy down x, then this bracket here. This bracket now has power of 3 only. Power of 3 only. So this step okay or not? This step. This step. Okay or not so far? If okay, then I proceed.
Wait, teacher.
Okay. So okay, then you look at this, the term in front and the term at the back. They have common factors. The two of them, they have one common factor. The common factor is 1 plus 3x. Now here is 1 plus 3x to the power 3. Here is 1 plus 3x to the power of 4. So the common factor is 1 plus 3x to the power of 3. So I take out 1 plus 3x to the power of 3. So when I take out 1 plus 3x to the power 3, I put in front here. Then I create another bracket, the square type of bracket. The 2 I didn't take out, so the 2 is still there. Power of 3 take out, power of 4 take out power of 3, you are left with power of 1. So you are left with power of 1. For the term behind, the whole thing has taken out. So you are left with 24x only. Okay. So the session is going to end here. I will give you a new pass to get in. So you think about this.
Teacher, I don't understand.
Don't understand. You wait for the new session. The 40 minutes is up already. 40 minutes up. Wait for the new session. Wait for them to end by themselves. Or can I end it?
Can, teacher.
Can, end,